December 15th, 2025. The Day 3I Atlas will pass closer to Earth than any interstellar object in recorded history. Across the planet, hundreds of observatories are on alert. Telescopes in Hawaii, Chile, and Spain have been tracking its approach for months, each frame revealing something more unsettling. What began as a faint green dot beyond Jupiter has now become a cosmic event that could rewrite everything we know about how space behaves. Scientists are split into three camps. Some believe 3I Atlas will simply glide past and disappear forever into the darkness. Others warn that its unusual chemistry, rich in nickel but lacking iron, with an 8-to-1 ratio of carbon dioxide to water vapor confirmed by Keck Observatory, could trigger unpredictable energy reactions as it crosses Earth's magnetic field. And then there are those who fear something far stranger, that it might emit a signal or even respond to one, because the moment 3I Atlas entered the Sun's influence in October, physics stopped making sense. Its tail turned backward, defying solar wind, and its speed began to fluctuate like a living pulse. Something out there isn't following the rules, and on December 15th, it's heading straight for us. It began on the edge of the solar system, far beyond the orbit of Neptune, where sunlight fades into silence. Early in 2025, a faint green glow appeared in the data from the Pan-STARRS Observatory in Hawaii. At first, astronomers thought it was just another icy traveler, a comet passing through on its way out of the galaxy. But the more they studied it, the less sense it made. Its name was cataloged as 3I Atlas, the third interstellar object ever discovered by humankind. Unlike any comet before it, 3I Atlas moved as if it ignored gravity itself. It sliced through the outer system at nearly 150,000 miles per hour, crossing Jupiter's orbit and then Mars's path without losing speed. The strange object seemed to glide effortlessly through space, its motion smooth and deliberate, as if it were being guided. For months, observatories around the world gathered data, and every new reading deepened the mystery. Its composition contained nickel vapor but no iron, something that shouldn't exist naturally in space. Its gases burned an unnatural blue-green, and its tail didn't behave like dust or ice. It bent, pulsed, and shifted direction against the solar wind, like a jet adjusting its thrust. By late October, 3I Atlas entered what astronomers call a solar conjunction, the point where it passes behind the Sun from Earth's perspective. It vanished completely. Every radar echo, every optical trace, gone. For nearly a month, humanity was blind. No telescope could see it. No signal could find it. And that silence changed everything. When 3I Atlas finally reappeared in late November, it was no longer the same. Its glow had intensified, its surface now shining twice as bright as before. The gas emissions flared with rhythmic precision, repeating every 17 minutes, as if something beneath the surface was pulsing. Even more disturbing, its trajectory had shifted. Instead of continuing outward, its course now pointed directly toward Earth. The data from NASA's Jet Propulsion Laboratory confirmed what no one wanted to believe. On December 15th, 2025, 3I Atlas would reach its closest approach, only about 1.8 astronomical units away, roughly 170 million miles. That might sound distant, but in cosmic terms, it's uncomfortably close. Close enough for its magnetic field, radiation, or debris trail to interact with Earth's upper atmosphere. Some researchers insist it's still a natural comet, a rare survivor from another star system. Others point out that no known comet could maintain such speed, defy solar radiation, and then reorient itself with such precision. Something about it feels intentional. Every telescope, every satellite, every radio dish now watches the same point in the sky. All the data converge toward a single date, December 15, 2025. The day 3I Atlas will come closest to Earth. And the only question left is this: will it simply pass by, or has it come to do something to us? On October 29, 2025, 3I Atlas reached its perihelion, the point where it passed closest to the Sun. For a normal comet, that's when death begins. Solar radiation tears icy bodies apart, stripping away their cores and scattering them into dust. But 3I Atlas didn't die. It did something no object in history had ever done. As it crossed the Sun's burning influence, images from NASA's Solar and Heliospheric Observatory revealed an impossible sight. Its glowing tail, instead of streaming away from the Sun, turned inward, pointing directly toward it. The direction reversed completely, like a jet firing against the solar wind. At first, mission engineers thought it was a sensor glitch, but cross-analysis from the European Space Agency's Solar Orbiter and the Japanese Hinode mission confirmed the same phenomenon. Every instrument agreed. The reversal was real. The solar wind around the object was blowing at nearly 900,000 miles per hour, strong enough to rip plasma straight from a star. Yet 3I Atlas pushed back, maintaining perfect stability. The tail didn't flicker randomly. It pulsed in measured intervals, alternating from emerald green to deep blue. The pattern repeated every 17 minutes, a frequency no natural outgassing process could explain. Researchers called it the sunward reversal event. It was the first and only time a comet had ever defied solar dynamics so completely. Models predicting energy output and particle motion all failed to match the data. Instead of weakening under the Sun's heat, the object grew brighter, its luminescence doubling while its shape held steady. Spectral readings from Keck Observatory detected periodic bursts of nickel vapor coinciding exactly with the tail's changes in direction. While water signatures nearly vanished, that meant 3I Atlas was transforming energy instead of losing it, possibly converting solar heat into power. In private research notes shared through the International Astronomical Union, several astrophysicists described the behavior as a reaction opposite to entropy. In other words, the closer it got to destruction, the more stable it became. By the time 3I Atlas left perihelion, it had endured temperatures that should have vaporized any comet. Its orbit remained intact, its surface unscarred, its brightness steady. It had survived the Sun. And for the first time, scientists dared to ask the question that rewrote everything they thought they knew. What if 3I Atlas wasn't a victim of solar energy, but a collector of it? If so, its journey toward Earth wasn't random motion through gravity. It was an active direction, a decision. When astronomers studied the reflected light from 3I Atlas after perihelion, they found something no one could explain. Spectroscopic readings from Keck Observatory and the European Southern Observatory showed pure nickel gas venting from the object, nearly 4 grams per second, but no trace of iron. In astrophysics, that's unheard of. Nickel and iron are cosmic twins. They're created together inside supernovas and always exist in the same ratio in asteroids, meteors, and planetary cores. To separate them completely would require controlled temperatures and chemical refinement that nature simply doesn't perform, but 3I Atlas was doing it, continuously. Its reflected spectrum glowed with the metallic signature of pure nickel, shining like mirror-polished armor under the sun. Independent confirmations came from multiple observatories across Chile, Japan, and Spain. The data was clean, consistent, and rhythmic. The vapor output pulsed every few hours as if following a timer. Nickel is one of the most heat-resistant and reflective metals known. It's used in spacecraft alloys and radiation shielding to regulate temperature. The more scientists looked, the more 3I Atlas resembled an engineered system, one deliberately designed to withstand intense solar exposure. Several research groups proposed that the nickel emission wasn't a random byproduct, but part of a temperature control mechanism. It could be reflecting or dispersing heat while maintaining internal equilibrium, much like how modern spacecraft radiate excess energy through specialized panels. Radar scans from ground arrays in Australia and Spain added another layer of intrigue. The object's internal density didn't match its surface readings. Instead of a solid nucleus, data hinted at a hollow structure, possibly containing cavities or chambers. The way light scattered off its core suggested a multi-layered shell, absorbing specific wavelengths and amplifying others, as if managing energy flow from the inside. One international materials science team compared its reflectivity pattern to engineered metal composites used on Earth. Their conclusion was careful but clear. No known natural process can explain this purity or consistency. If that assessment holds true, 3I Atlas might not just be coated in nickel, it could be built from it. That would make the outer layer less a crust of ice and rock and more like a protective hull, a skin designed to endure heat, radiation, and time itself. And if that's the case, then whatever lies inside that metallic shell might be something far beyond a comet, something created, something waiting. When the James Webb Space Telescope finally captured a clear spectrum of 3I Atlas, the data defied every known rule of comet chemistry. The readings showed a carbon dioxide to water ratio nearly 8 times higher than that of any natural comet ever studied. Normally, frozen water dominates the composition of these icy travelers, with small traces of carbon compounds mixed in. But 3I Atlas reversed that balance completely. It expelled carbon dioxide in massive amounts while releasing almost no water vapor at all. At first, astronomers suspected instrument errors or solar glare interference, but repeated scans from multiple facilities, including the Webb telescope, the Very Large Telescope in Chile, and archived data from Spitzer, all confirmed the same result. The signal was stable, consistent, and real. The emission pattern wasn't random, it pulsed. Every 17 minutes, the CO2 release spiked in perfect rhythm, the same timing previously detected in its tail during the sunward reversal event weeks earlier. It looked less like a natural venting process and more like a controlled system. Several researchers described the phenomenon as a closed-loop reaction, suggesting that 3I Atlas could be absorbing solar energy and releasing carbon dioxide as a byproduct, a behavior no known comet has ever shown. One study from a European planetary chemistry team compared it to a circulatory mechanism, a structure capable of balancing heat by taking in radiation and exhaling gas in measured bursts. In simple terms, it was breathing. If that interpretation is correct, it would mean 3I Atlas possesses an internal energy source or regenerative thermal process, something capable of maintaining equilibrium while exposed to intense sunlight. In nature, that kind of thermal regulation only exists in living systems or engineered machines. Other scientists proposed a more mechanical explanation. The consistent gas cycles could represent a self-cooling mechanism, a way for the object to stabilize internal temperature and pressure while moving closer to the sun. Yet even this theory couldn't explain the precision of its timing. The CO2 output followed patterns too regular to be chaotic. As 3I Atlas continued toward Earth's orbit in late November, its carbon dioxide output increased again, nearly doubling within a week. The pulses grew faster, as if something inside was responding to changing solar conditions. Telescopes captured faint shimmering waves of blue-green light across its surface, each emission rippling outward like a heartbeat frozen in space. It no longer behaved like a comet, it behaved like a system, and that led to the question no one could ignore. What kind of system breathes in sunlight and exhales gas in perfect rhythm? Was 3I Atlas an ancient energy technology designed to feed on stars, or something alive, operating on a scale humanity has never understood? Between late October and November 2025, humanity lost sight of 3I Atlas. It entered what astronomers call the solar conjunction, the period when an object moves behind the sun, making it invisible from Earth. During that time, every telescope, every radar system, and every probe went blind. The combined instruments of NASA, ESA, and JAXA all registered the same thing: silence. For nearly 4 weeks, no signal returned, no reflection appeared, and no one knew where the interstellar traveler had gone. Ordinarily, this kind of blackout happens with comets all the time. They pass behind the sun, then reappear days later, following the same path. But 3I Atlas had never followed the rules, and this time was no different. When it finally emerged from the other side of the sun in late November, it was changed. Its brightness had doubled. The reflective intensity of its nickel shell was far stronger than before, and its color had shifted slightly, the blue-green hue now flickering like a pulse rather than a steady glow. More troubling was the trajectory. Radar and optical measurements showed a deviation of nearly half a degree, small but significant for an interstellar object. Its direction had tilted closer toward Earth. At the same time, the rotation rate had slowed dramatically. It was no longer tumbling freely through space, but spinning with steady precision, as though under control. That detail set off alarm bells inside observatories worldwide. Data from NASA's Jet Propulsion Laboratory suggested that to change rotation and heading without any visible outgassing or impact would require a force applied from within. Some speculated it could be due to uneven heating or gas jets hidden beneath the surface, but the numbers didn't add up. The torque required was too precise, too balanced. Harvard astrophysicist Avi Loeb, who has been studying interstellar objects since the discovery of Oumuamua, described the observation as deeply disturbing. In an interview with Scientific American, he said it challenged the most basic models of celestial mechanics, the idea that natural bodies move only under gravity, radiation, and chance. If this data is correct, he noted, then 3I Atlas is behaving as though it has guidance. That single phrase, "as though it has guidance," spread across the scientific community like a chill. Every agency rechecked its logs, hoping to find an error in the missing data. None did. The blackout remained a perfect void. And that void became the scariest part of the story, because no one knows what happened while it was hidden behind the sun. Did it interact with solar energy in ways we can't yet explain? Did it change internally? Or did something inside it wake up? Whatever occurred in that month of darkness, it returned stronger, brighter, and heading straight toward us. In the silence of space, something moved behind the sun, and when it came back, it was not the same. Some scientists now whisper the unthinkable. In that darkness, 3I Atlas might have awakened. By early December 2025, 3I Atlas had passed the orbit of Mars. From that point on, something extraordinary began to happen. Telescopes across the world, from the Lowell Observatory in Arizona to the European Southern Observatory in Chile, started detecting a deep emerald glow surrounding the object. The light wasn't constant. It flickered in a perfectly timed rhythm, pulsing every 17 minutes with unwavering precision. At first, observers thought it was an artifact in the imaging data. But multiple independent measurements, taken from both ground-based facilities and orbiting probes, confirmed it beyond doubt. The rhythm was real. The pulses were identical. Every 17 minutes, the intensity of the green light surged, plateaued, then faded, only to repeat again, as steady as a heartbeat. Astronomers quickly realized that nothing natural behaves like that. Typical cometary outgassing is chaotic, irregular, and dependent on sunlight or rotation, but this was stable, synchronized, and seemingly deliberate. It didn't change with distance, didn't fluctuate with solar radiation, and didn't correspond to any rotational pattern. It was as though something inside 3I Atlas was running on a schedule. Researchers from NASA's Goddard Space Flight Center analyzed the brightness variations and found an exact periodicity to within 1/10 of a second. That kind of consistency is common in engineered systems, oscillators, transmitters, power regulators, but not in drifting rocks or ice. Some suggested it might be an internal resonance, the echo of an energy field bouncing inside a hollow shell. If 3I Atlas were hollow, it could function like a gigantic resonator, absorbing solar energy, storing it, then releasing it in pulses. Others compared the effect to a capacitor charging and discharging over time, each cycle emitting visible light as a byproduct. The European Space Agency's spectroscopy teams detected faint secondary emissions during each pulse, tiny bursts of near-ultraviolet radiation synchronized with the green glow, as if the light carried structure or encoded information. The data looked less like chemical reactions and more like communication. Still, no one could explain why the timing was so precise. The pulse didn't drift even when the object accelerated slightly on its approach toward Earth. To maintain that stability in deep space would require constant regulation, like a heartbeat controlled by an internal rhythm, or a signal maintained by machinery. For many scientists, it was a moment of silent reckoning. If this rhythm was natural, it could reveal a new form of cosmic physics, a self-regulating system fueled by starlight. But if it wasn't, if that emerald pulse was a form of emission rather than reaction, then humanity might be witnessing something more, something thinking. The pulse continues, steady and unbroken, echoing through the vacuum between Mars and Earth. And as it grows brighter with each passing day, one question now haunts every observatory on the planet. Is that green light the reflection of nature or the signal of intelligence? As December 15th draws near, every observatory, satellite, and research agency on Earth is watching 3I Atlas. It will pass closer to our planet than any interstellar object in recorded history, roughly 1.8 astronomical units, about 170 million miles. On that day, humanity will finally learn whether this visitor is just a wandering comet or something entirely different. Scientists have outlined 3 major possibilities, each one more unsettling than the last. The first is the safe scenario. In this outcome, 3I Atlas will simply glide past Earth, continuing on its outbound path through the solar system. It may leave behind faint magnetic disturbances or minor radiation echoes, like ripples spreading through the cosmic fabric, but nothing catastrophic. Some models predict that its green emissions might temporarily interfere with radio frequencies or polar atmospheric currents, causing unusual auroras near the poles. If that's all it does, it will still go down as one of the strangest natural events in modern astronomy. The second is the transformation scenario. In this version, proximity to the Sun's radiation pressure and Earth's magnetic field could trigger a reaction inside the object. The nickel shell might heat unevenly, causing asymmetric gas release, or worse, a controlled burst of thrust. If that happens, 3I Atlas could change velocity or direction mid-flight. A sudden energy flare, a beam of gas, or even a visible plasma jet might appear. something not unlike a propulsion maneuver. Observatories have already prepared contingency plans to monitor any acceleration spikes or electromagnetic surges. Should it react again, it would confirm that the object doesn't merely survive its environment, it adapts to it. Then comes the third and most controversial possibility, the communication scenario. Over the last several weeks, telescopes have detected increasingly structured fluctuations in 3I Atlas's light curve. The green pulses remain precisely timed at 17 minutes, but recent readings suggest faint modulations, variations that repeat in mathematical intervals. To some analysts, it resembles an encoded sequence, perhaps a form of photonic transmission. Others argue it could be coincidence, but the data doesn't rule out the idea that the object might be emitting information rather than light. If that's true, then the green glow could be more than reflection. It could be a message, a signal broadcast toward Earth, Mars, or something farther still. Governments remain silent on whether they've attempted to respond, but insiders from multiple space agencies confirm that private labs have begun decoding the frequency shifts in the optical data. If a pattern is found, if those pulses align with known mathematical constants like prime numbers or the Fibonacci sequence, it could change everything we know about our place in the universe. For now, no one can predict what will happen when 3I Atlas reaches its closest point. But whether it passes by quietly, transforms under solar pressure, or begins to communicate, one fact is undeniable. For the first time in history, humanity is about to witness an interstellar object that seems to know exactly where it is. December 15th, 2025, the date that has been marked on every scientific calendar for months. At roughly 1.8 astronomical units, 3I Atlas will pass at a distance far enough to keep us safe, yet close enough for humanity to see every detail with stunning clarity. Every major telescope on and beyond Earth will be watching. The James Webb Space Telescope will capture it in infrared. Keck 2 will measure its spectral fingerprint. From Mars, orbiters like ESA's Mars Express, China's Tianwen-1, and the UAE's Hope probe will record it from another angle. For the first time in history, humanity's instruments across two planets will point at the same object, a visitor from the stars. The scientific consensus is cautious but unified. 3I Atlas poses no direct threat to Earth. There is no collision course, no apocalyptic impact. But its behavior defies the logic of everything we thought we understood. A tail that moves against the solar wind, nickel without iron, rhythmic pulses of carbon dioxide breathing like a machine, or a living thing. We may not be in danger, but we are being confronted with something profound. If 3I Atlas was built, sent, or guided here, then December 15th could mark more than an astronomical event. It could be the moment humanity realizes we were never alone. The telescopes are ready. The sky is waiting. And soon, the signal, whatever it is, will arrive. What do you think will happen when it finally reaches us? Don't forget to subscribe to MindGap and share your thoughts below, because maybe, just maybe, the sky is about to answer.